Hello friends, welcome back to this tutorial series of Jetpack Compose, and in this tutorial we are going to learn about next effect handler, that is ProduceState. So when we want to create a compose state in our UI based on some type of suspending result with multiple state updates, then ProduceState is the effect handler which can help us to do that very easily. I know the formal definition might sound a bit little unclear for now, but let's jump into Android Studio so that we'll see it practically there and it will make much more sense. So here I am in an Android Studio project. I have created a separate file for this demo, and here I have created a new composable function that is named as ProduceState demo. So here we are able to see the preview of this one, and let's say I want to create one type of counter here. So I'll just take one text composable here, and initially I'll give it a value as 0. I'll use a modifier equal to modifier dot fill max size, and also dot wrap content size, so that it will come at the center. Okay, so you can see by default alignment is center, that's why it will come at center. I'll also apply some type of style to this text style. I'll just increase font size equal to 50 sp. Now you will be able to see that more clearly. Okay, so we have this 0, and now I want it to update it one by one, increment by one with each second. So how can I do that? For that I need to make this text as a state and update it. So I have the requirement which fits in launch effect block as well. So I'll first use a launch effect block. So for that I'll first create a state here where counter equal to uh, sorry, we can just use by remember, and I'll just write mutable int state of, and I'll just write it initially as a 0. Then we can use this same counter here. We don't need this double quote, and we also make it as a toString. Okay, now the error is gone, and you'll be able to see that the result is same. So this is now state. We can make it as val, and for make it to update continuously, let's say some type of API call we have, and from there we are getting some type of result, and we want to update this state. So for that I am launching this launch effect block for the to execute some type of coroutine here, and for the key I'll just write it as true as a constant value, so that this launch effect block will never be recomposed, because we don't need recomposition of this block. Now here I'll, in order to simulate some type of API call, I'll just write a delay here of 1 second. Okay, and here I'll just write counter plus plus, and to what happened here? Okay, sorry, I need to make it as a var, and in order to keep it incrementing I need to wrap it with a type of loop. So I'll just write a while and just pass it through here, so that the loop will continue infinitely. And yes, that's the only thing we need to do. So whenever we'll increment this counter as this composable state, it will notify this text composable here, and this whole composable function will be recomposed. So let me start the interactive mode here, and you can see that it already started working as we were expecting. So that's the thing we are able to achieve with the help of this launch effect as well. But the produce state can provide a better solution for this one, better alternative. It will perform the same task but with the less code and more readable code. It we can say at it will just provide some type of sugar coating around that. So I just select this part, clear this, and directly write here produce state. It requires an initial value. I'll just write 0, and here in the block I will again do the things. Okay, I need to change it to val, and here I can now, if I hover on this one, so this is a suspended block, so we can launch coroutine easily inside this lambda block. So I'll again write loop, sorry, type of loop here, while, and the while is will be a true. Here I'll write a delay function, will delay by 1 second, and then I'll just write value. Now I don't need to write again counter plus plus. Instead we can just write value equal to value plus 1, so that this value is actually assigned to this counter. So we can also write it as a plus equal to value plus 1. So, and if we update this value, then it will update this counter value, and as soon as this counter will be updated, this text composable will be decomposed. So let's run the interactive mode again with this produce state and see. And yes, we are getting same type of result. So that means uh, we don't need this launch effect. Instead we can use this produce state, and with a clean code we can achieve this task. So if we have some type of such a requirement where we want to create an API call, make an API call here to get a coroutine context and which has a continuous updation of state, then we can use this produce state. But pretty much these things we can do from a view model and live data observer. So you might not need this much frequently in the real life projects, but still uh, this is how it works. The another effect handler I also want to discuss it here. I am included this in this video itself because it is so much small and it you won't require it anywhere. So that is a side effect. This is one type of again effect handler. But if we want to use a block, if you want to launch some type of a non-composable code in compose function, in a composable function, then we can use this block, and this block will be triggered every time this composable will be recomposed. So in order to demonstrate that, I'll just write one log statement here. We'll make it as a my attack, and we'll write side effect triggered, and here we won't be able to see it here. We need to launch it on our emulator. So let me clear the logcat first and launch the specific. So every time this value gets updated, this whole composable will be recalled, and this side effect block will also be recalled. So every time it gets recalled, this log statement will be printed, and we'll be able to see it here in a logcat. Sorry, I selected another device. Let me select this one, emulator, and now I launch it. Okay, let's go to our logcat and just observe. See, for every updating state, you are able to see this side effect triggered block statement. So this side effect block is getting triggered for each and every composition. If you hover on this one, this is a non-composable lambda, but this doesn't provide a suspended context. So we cannot call any suspended function here. If we call suspended function like a delay, it will ask us to launch a separate coroutine. So we can't launch a coroutine here, but if you have something that is a non-composable code, but we want to get triggered it for every recomposition, and it is something that is not related to composition, we can use this block. But if you ask me, then you won't need it anytime. I just showed you just to make you familiar that this also exists, so that you won't be surprised where if you come around this type of block somewhere else. So that's it about these two effect handlers, produce state and the side effect. So if you have some doubts regarding this one, then you can put your questions in the comment box below. I will try my best to answer those. If you have some type of doubts, you need some clarification regarding some projects or some type of guidance, then you can join the WhatsApp group of AshishMobileDev. The link is in the description and a first pinned comment, so that you will be get a chance to ask your query directly in the WhatsApp group, where you will find another developers like-minded. So if you like this video, then please click on like, share with your friends, and don't forget to subscribe to the channel, so that whenever a new video is published, you will get notified. We'll meet in the next tutorial with some another interesting topic. Till then, goodbye.